When we're talking about all the numbers you've been exposed to up to this point, we're really talking about complex numbers. Complex numbers include i's, meaning the square root of -1, but they also include numbers that don't have i's in them. The numbers that don't have i's in them are just the real numbers. In other words, if you look at a form of a complex number, all complex numbers can be written in this form here. However, when you don't have i's, the number in front of I has to be 0. So they're always a number plus 0i, so that just disappears. So it would be like a 5, could be a fraction, could be pi, could be the square root of 2. Those are all examples of real numbers. Pure imaginary numbers only have an I, but nothing added to them. So like a 5i or a negative 7.85i. In general, imaginary numbers are just complex numbers where they have the real part and the I part, the imaginary part. They need to have both parts. When you look at real numbers, they can actually be broke down into farther or subgroups. Rational, meaning it could be written as a fraction, and irrational, those that cannot be written as a fraction. Decimal-wise, they go on forever and never repeat, never terminate. Those would be like pi or e or the square root of any number that doesn't work out nicely. Now, the rational group right here can actually be broke down into farther subgroups. Integers, those that don't have to be written as a fraction, and non-integers, those that can only be written as a fraction. The integer group right here can actually be broke down into subgroups. Natural numbers, which are only the positive versions of the integers, the negative integers, and then the one number that's not positive or not negative, and that's 0. Now, all this can also be represented graphically. The whole big box, everything in there is a complex number. However, if you're inside the black oval, then you're also a real number. And you'll notice the real numbers are split into two groups, the irrational ones and the rational group. You'll notice that rational group is split into a subgroup of integers, and those integers are actually broken into another subgroup of natural numbers. So, we want to go ahead and classify each one of these. This one here is a natural number. This one here is a negative version of a natural number, which is referred to as an integer or a negative integer. This one here is a decimal, but it doesn't go on forever. It terminates, so therefore it's rational, meaning it could be written as a fraction. This one here is a fraction, so it means it's rational. This one here only has i's in it, so we would classify it as imaginary, but more precisely because it has only i's, it would be pure imaginary. This one here has the i's, but it also has the real part, so we just say it's a complex or imaginary number. This one up here is the square root of a number, and if it doesn't work out to be nice, then it's an irrational, which it is. However, when you look at the next one, the square root of 49, that actually works out to be nice because that's just 7. 7 is just a positive integer, which is referred to as a natural number. Then we have 5 to the 1/3 power. You should remember the 1/3 power really means the cube root of 5. Well, cube root of 5 doesn't work out to be nice and neat, so it's an irrational number. When you're dealing with a negative first exponent, it really just means take the reciprocal. Remember, reciprocal means flip your fraction upside down. This is really just a 5 over 1 raised to the negative first, so it means flip your fraction upside down and you get 1/5. Now, you could say that this one here is over 1, and therefore you got to flip it upside down. And if you flip that upside down, then you get a 1 on top, you get a half on the bottom. But instead of dividing by half, remember you want to multiply by the reciprocal, so we take what we have on the top, multiply it by the reciprocal of this, so you got to flip that upside down, and so you just get 2. Or you could have thought of it as just, well, I got to just take the reciprocal of a half, and that's my 2. You could have done that also. How do we multiply or add fractions together? You got to have a common denominator. How do you multiply fractions? Well, you just multiply the tops, the numerators, and multiply the bottoms, the denominators. We just talked about dividing fractions. You don't divide fractions, you multiply by the reciprocal, and it's always of the second fraction. Now here, we want to figure out, is this answer right here that we're dealing with going to be a positive answer or a negative answer? So when you're looking at this, you want to know positive or negative. Well, it says that x is less than 0, so you know x is negative. It says y is greater than 0, so you know y is positive. So this one here is really a negative, because that's your x, over a positive, which is y. Well, a negative over a positive is negative. When we look at the second one here, it's y, which is positive, over x, which is negative. So that's what we're saying here. Dividing two numbers of opposite signs, you know you get a negative answer. So then you're just adding two negatives together. And a negative plus a negative is a negative. Here we're looking at absolute value. Absolute value is distance from 0 on the number line. And you know distance is always positive. So 5, that's just 5 units to the right on the number line. So you know your answer is 5. Absolute value of 4, negative 4, you know you're 4 units less, so you know your answer is 4. But the question is, what are you really doing to that negative 4 to be able to get a positive 4? Well, you're really taking the inside of the negative 4 and you're multiplying it by a negative 1, because that negative times the negative makes it positive. So when we look at this in general, if you have the absolute value of a positive number, it's just that positive number, because that's what it was up here. Absolute value of 5 was 5. When it's positive on the inside, absolute value doesn't do anything. But when it's a negative on the inside, you know you got to get a positive answer, and all it does is it takes the inside and multiplies it by that negative 1, just like we did up here. We took the inside of our negative 4 from our absolute value, multiplied it by a negative 1. And you know a negative times a negative is your positive answer. Now what we're just talking about up there in mathematical speak is given to you in this formula here. It just says if you start with a positive number and you put it in, absolute value does nothing. It says, however, if you start with a negative number and put a negative in your absolute value, you get out the opposite of that. And that's what we're saying right here. When you're looking at this notation right here, D and then in parentheses AB, that means distance from 0, or distance between the 2 points. To find your distance, all you do is you do the absolute value and subtract the 2 coordinates. We got to have the absolute value because you know distance is positive. So if we're looking at the distance between x and 8 and we want it to be greater than 1, well, the distance, you know, you're going to have to go ahead and subtract these two. But we got to have the absolute value in there because we got to make sure it's positive, what we get out. The greater than 1 is given to us by this. Now, when we're dealing with the distance between two numbers, the order in which you subtract doesn't make a difference because you have your absolute value there, so that makes it positive. So you could really have 8 minus x in absolute value greater than 1.